we solve the seating arrangement.
We are pretty tight. It's actually a bit chilly in here, so I think it's comfortable sitting close.
Hi, welcome. First of all, maybe just if you could introduce yourself in 30 seconds and explain what you do in AI.
Yeah, hi everyone. I'm Prakul. I'm a product manager at MongoDB focused on AI. We have a vector search product that I work on and some other initiatives around natural language to MQL conversions. We see a lot of like retrieval-augmented generation use cases, etc. And previously I was in the self-driving car with Amazon Zoox, working on the ML platform. And in the previous life was a founder building an app for playing the right music at the right time using machine learning.
Hey everyone, I'm James. My background's actually in large-scale infrastructure, so building databases and storage systems and that kind of stuff. I have a startup called Convex, and it's a backend as a service. And I think what's particularly relevant for the AI crowd is that we have many thousands of AI apps being running on Convex and being actively developed on Convex. So my experience is basically, I built AI apps myself, like AI Town, which was worked on AI Town, which was relatively successful. But seeing what apps look like in the real world, basically, and especially companies that are making money off of AI, how do they architect their applications?
All right, thanks. So I'm Emmanuel. I'm the founder of Airtrain.ai. We have a booth out there, essentially a no-code fine-tuning and evaluation platform. So my background is also in ML infrastructure. Before starting this company, I used to lead the ML infrastructure team at Cruise, the self-driving car company, where we built all the orchestration layer for training pipelines and so on. And so now we're building this knowledge to the AI crowd to help them run those heavy pipelines without necessarily knowing how to write them or orchestrate them on cloud compute. So yeah, that's me.
Okay, thank you. So maybe before starting the discussion, a few words on RAG and fine-tuning. If you are not aware, RAG, retrieval-augmented generation, is a practice of bringing relevant information in front of the large language model at the moment of prompting. Fine-tuning, on the other hand, is a practice of training a model on your own data so that it has prior knowledge of what you are asking. So maybe, what's your take on fine-tuning?
Yeah, so for fine-tuning, so if you're trying to make use of a large language model for your specific use case, there are three main methodologies: prompt engineering, RAG, and fine-tuning. So fine-tuning is useful for certain context. Independently, depends on the use case. It is useful with some other methodologies alongside prompt engineering, alongside the retrieval-augmented generation. So it really depends, right? But we are super excited to be seeing the newer fine-tuning methodologies coming out, which lets you really get the desired behavior out of a model based on fewer data sets, able to do it quickly. But there are limitations in terms of how do you do the data governance, the data that you will be using for essentially fine-tuning a model. There are certain challenges. So that's generally where the advice will come in. Like if you're trying to do something which can be done without fine-tuning, it's good, can get you faster. But new style, new language, that's where fine-tuning shines, and that's where we leverage it.
Yeah, I think there's applications where fine-tuning is extremely relevant, and obviously things like self-driving cars or speech synthesis. It's where the quality of the model and the tailoring of the model to the use case has real primacy. I think there's also a huge category of applications and applications that I see getting built where the quality of the model just doesn't actually matter that much. It has to be good enough, but some variant of ChatGPT or GPT or Llama is okay. And for these applications, what matters is relevance to the state the company has or freshness or recency. And I'll talk more of that in the RAG section because Emmanuel's the expert on fine-tuning.
Yeah, so the way that I see things today is that we have those huge models, the GPTs of the world, the Gemini and so on, the Claudes. But it's not really realistic to build every application on top of those huge beasts of models because they're very slow, they require a lot of resources, they're very expensive. And also, you don't own those models. They're owned by those other companies. So when you're prompting them, you're sending out your data, maybe your customers' data, out to those other providers. And so that's great to prototype, to get a sense of whether your product can work. But I think in the future, it will be much more made of smaller models like, Mistral 7B, Phi 2, Llama, and so on. But in order to get those models to perform as well as larger models on specific applications, you may need to fine-tune them on high-quality data sets to get them to perform well, at least on this particular application. So I think the future is made of fleets of small models. Every organization, every company will have a fleet of a few dozen, a few hundred small models. Think of them as like microservices of small models. Some of them will be just off the shelf, and some of them will have to be fine-tuned to get the models to speak a particular voice, whether it's actually the way they express themselves or a particular format. For example, if you want to have a model that generates consistent JSON payloads or XML payloads or SQL, you may have to fine-tune the model to always return good JSON, good XML, good SQL. So I think this is where fine-tuning comes in to shape the outputs of the model, not necessarily to give him more knowledge, but to shape how the model is going to speak, what voice. If you're trying to do legal content or medical content or Harry Potter or any type of character content, then you may need to fine-tune for that purpose. So it gets you those small models to perform just as well as the big ones on specific tasks. So this is what fine-tuning comes in.
Great. And what about retrieval-augmented generation?
So you can just get started. So retrieval-augmented generation, this is a primer, is this emerging pattern of using a generative model by augmenting it with a retrieval model that can basically act as a knowledge source. So if you're basically trying to answer a customer service question on your data set, if a customer asks you a question like, how do I solve this problem, right? So you need the information about understanding from all the data that they have on Salesforce about that customer, about this specific issue in Jira maybe, and you need information about the company, right? What products they're using, what are the ways to solve it based on previous answers. So putting together all these diverse knowledge sources, being able to feed it to an LLM to provide the second natural language answer to the question that the person asked. So with RAG, we are essentially combining a retrieval source, in this case, a vector database, that can essentially query your knowledge sources based on your natural language input, right? So you're not relying on the traditional keyword-based search as you would do in a traditional retrieval. That's where you're using an embedding model, which is derived from a large language model, understands your language context. So to get to this point, you could have baked all that knowledge about your company, about the customer, into a model which is fine-tuned based on coming on top of this, right? So there are key challenges which come in this kind of a use case. Firstly, this knowledge is changing continuously, so you will need to fine-tune the model, right? So fine-tuning is expensive. The second thing is your data governance issues. So different people in the company, organizations have access to different levels of data. With fine-tuning, it's not possible to be able to have that data lineage, that kind of a governance, which becomes possible when you're using a retrieval mechanism, like a vector database, vector search. Third piece is about the hallucination and citation. So with RAG, since you're retrieving, you're able to provide much better explainability for a certain answer. Your output can basically provide, these are the sources which are governed and accurate from your database that are being used to generate this answer. That way, explainability, hallucination are significantly improved. So yeah, I'll let to the panels.
Yeah, I'm particularly interested in AI from this, capitalist perspective of how can it enhance an application that actually solves user problems. And I think for most of these, what really matters is some sense of relevance or recency or freshness. So it's basically, yes, the model is doing the human side of things, like answering questions in a natural way and doing approximate answers. But there's also a computer side of things, right? Which is involves stuff like a database, which stores, your list of meetings that you're summarizing or your previous chat history. There's a likely vector search that you're using to kind of consult embeddings from this to generate context to provide to the model. And you need an execution platform for doing this, including workflow that can schedule these things, right? So I think most businesses that are making money off an application, they want to know the user state. They want to have that user state in a database. They want to be able to consult it in a year's time. They want to be able to make business logic decisions on these. And I think RAG is a really great fit for this, where you can have your business and your data and your state, and then use that to augment answers from a model. Now, you might want to go and fine-tune that model periodically, but that model's not going to get fine-tuned on every request, at least not with current technology, right? What you're doing in every request is saying, hey, here's some state about this user. These are the items we have in stock, and here are some reviews, and these are the user's preferences. Now give me an answer. And I think, I'm obviously going to shield Convex because that's my platform for orchestrating these things. But I think there's this common ingredients of like vector database, database vector search, execution, workflow, and serving.
Yeah, I think you're right. It's impossible to fine-tune a model on every user request. And even if it was possible, fine-tuning will not necessarily teach new information to your model. Fine-tuning will shape the output of your model to speak in a certain voice or a certain format, code, or whatever it is. So you have to think of models as like offline things. They do not know what's going on in the world. If you ask a model, what's the weather today, they won't know. So it basically knows as much as it was given at training time. And the training process is a very expensive process. It takes many weeks or months, costs millions of dollars. And so it's obviously not a realistic thing to do to have to retrain the model to teach it information. And as you all know, models hallucinate, which means that even when they have seen the data during training, they can just forego this data entirely and produce an output that sounds plausible, sounds correct, but is actually factually incorrect. So the best weapon at this time against those hallucinations is RAG, basically giving the facts, the data as part of the prompt and asking the model to restrict itself to only what is in the prompt to produce the output. So RAG is your best way to get around hallucinations. It's not foolproof, but it's your best way to get around it. So models are frozen objects in time at the time of training. The way to make them online objects that can actually interact with the world is to use RAG. Obviously that requires a little bit of infrastructure because you need to deal with ingestion of your data into the vector database. You need to have a good retrieval algorithm. You need to be able to also feed this data into the prompt. So it's a bit more engineering to set this up, but there's plenty of platforms out there, like Convex, for example, that let you do that. But it's the only way to fight hallucinations at this time and to make your models online and relevant, really.
Yeah. If I can add something to that, because I love that answer. If you think of this from a systems perspective, there are times where you don't want an LLM in the critical path of a user-facing decision. Because these things can be a little bit slow. Latency is not terrible, right? But sometimes they can be slow, and sometimes they can be a little bit unreliable. And sometimes you want an answer in milliseconds, right? So using AI does not mean you have to have always, a user input talking to a model and getting an answer, right? You can spend time in the background pre-computing stuff. You can generate embeddings and use vector search for retrieving results rather than going through using the model to compute the embeddings and just using vector search for the answers. So I think folks at least should disillusion themselves with this model that it has to be input, model, answer, right? The model is there, the model is powerful, the model is like the human in the loop, and then that can get built into a system. Okay.
Great. And how do you choose between the two?
How do you choose between the two? So I think as per the many points discussed here, like for fine-tuning, that was my go-to when I'm trying to teach it a different tone, a different language, a different model, right? So for the customer service chatbot example, there is a certain organizational language, right? If you're a medical company versus a legal company, the way your style of answers are, that's going to be very different. So that kind of a thing is great to teach a model via fine-tuning. You're teaching it that newer language, maybe like, you have expertise in, let's say, Python, and you want new data set on JavaScript. You teach it with that. You can't do that with RAG, and you can't do that with a lot of your prompt engineering. You would want to use RAG when it's about teaching the model new knowledge, right? So knowledge is always changing, and that is a perfect use case for RAG for the various examples that we talked about. So that's a good rule of thumb.
Yeah, I would basically ask the other party, like what is it that distinguishes your application? What makes your application uniquely special, right? Is your application uniquely special because you have a model just giving really, really finely tuned answers in ways that other companies can't produce? And there's definitely companies that's what makes them special. Or is your app special because it has a really good UX, or it works really well, or it's reliable, it's got a really compelling product experience, right? So for folks who live and die on the quality of their model, you probably know this already, and you should be using a platform like Emmanuel's going to talk about in a second. For folks where the model itself, the fine details, maybe don't matter that much, I would encourage them just to keep it simple, right? Just to use the simplest possible thing, get your application off the ground, get it running, see how people respond, see if the issue is that the model's not giving good answers, or maybe that you're not giving the right context, or maybe you've architected it wrong. So for me, from the perspective of the applications I tend to work with, it's build the app first in the simplest, most basic possible way, and then when it comes time to really distinguish yourself on the quality of the model, then invest in that area.
Yeah, that makes sense. I see those two things, RAG and fine-tuning, as somewhat orthogonal. They don't address the same need. If your model does not need to be online in terms of having current information, if your model is a summarizer does not need to fetch anything anywhere. It just needs to get things from the input and put them in a smaller form. So you don't need RAG. If your model is a summarizer that needs to always speak like Harry Potter or like whatever other, then you may need to fine tune it so that it speaks that language, right? So one practice is to make the model relevant with current facts. If your model does not need to be relevant with current facts, you don't need RAG. If you don't need the model to speak a certain language, or format the output in a certain way, you don't need fine-tuning. So those things are really orthogonal. Also, the engineering required to set up those two things are different. On the one hand, RAG, you have data ingestion, you have retrieval, prompting, and so on. On the other hand, fine-tuning, you need to know how to write a fine-tuning pipeline, run it on a GPU machine, how to export the model, how to then serve it. So the engineering requirements are different. So think about what you're able to do and what your application really needs, whether it's being online or being really specialized in one particular way of speaking.
Okay. So any last word or something you want to add?
Sure. Yeah. I mean, I've been talking a lot this way. It may sound silly, but I heard someone say this once and it really resonated with me, is to think of LLMs as humans, not computers. And I'm not sure if this resonates with other folks, but the way you interact with them as a really smart, knowledgeable human that sometimes makes mistakes and doesn't operate like a computer operates, right? Computers, there's someone will argue like databases are going away and programming is dead. I don't personally buy that. There's always room for logic and precision, and then there's room for really hard questions that humans can do a good job of solving, right? So I tend to think of an LLM as a human, and there's some areas where a really highly educated, heavily trained human is the right person for a job, and you should be using Airtrain for those situations. And there's situations also where you just need a generally competent person in the loop, and any old model may just solve your needs. And that's the framework that has helped me think about these things.
Yeah, I think in the future, everybody will be doing both anyway, depending on the application. You will have a fleet of microservices of models. Some of them will be doing RAG because they need relevant information. Some of them will be fine-tuned for one specific thing. So I think in a few years, we won't even be asking RAG or fine-tuning. Like, well, it's a different thing. It's like, if you ask today, should I use BigQuery or should I use Next.js? Well, they're different things. It's a database and it's an online thing, like different things. So I would encourage you to think of those things as two different practices for different applications, not competing things to make your model better.
I would agree.
Yeah, just to add to that, it's an intelligent human being with a high ego. It can make stuff up. So it depends on your use case, right? I'm talking about the hallucination piece where it can make up stuff with high confidence and convince you that what it's saying is right? So that kind of creativity can be useful for certain applications. So you want to go to production with that. But for others, high critical application, that's not useful. So I think a good example is the self-driving car world. So I didn't realize he's from Cruise. But putting a critical production system, like a self-driving car which has no driver, that's a autopilot versus a Tesla, which is a good co-pilot, is a good example, right? What is your application? What is your business need? can determine how quickly you want to move with using these knobs on RAG and fine-tuning.
Okay, thank you very much. So that was it.
All right, well, thanks.
Thanks.
Thank you, everyone.
Thank you.
A bunch of us will be at these booths back here if you want to come and say hi. Thank you.